The basic as the stuff today, it's pretty much the same as yesterday with what we're doing. The difference is today we're focused on the area portion as opposed to yesterday was all the perimeter part. Okay, that's why it was the circumference. It still is using all the sin triangle stuff you did yesterday. So using major arcs, minor arcs, semicircles, all that stuff. Okay, it's just the difference is today we're doing things called sectors of the circle, and the sector is just like, if you would have done this before, it would have been probably brought to you like it's a slice of a pie or pizza or something like that. That's pretty much all it is. Okay? So, why did I have that? Yeah, we did that. Okay. So, for the area of the circle, just to remind you of the formula, right? This is your pi r squared one. Okay? And keeping the difference between the two, right? Circumference was 2 pi r. Area is pi r squared, right? And units for area are always squared units. That should be your clue as to which one goes with circumference and which one's area. Because people get 2 pi r and pi r squared mixed up all the time. Units for area are squared, so the r squared has to go for the area point. Most people remember both of them. They remember 2 pi r and pi r squared. They just forget where they go. Okay, so the type of problems you're doing, just like yesterday you did some where they were just circumference, today you're going to be doing ones that are just going to be area of a circle. And then from there you'll build into the sector part. Okay? I'm going to do like 2 problems with the area of the circle just so, and I think I got ones with like fractions so you don't freak out with them. But your answers to stuff today, leave in terms of pi as much as you can. Like I said yesterday, and even on the going through the homework, if the radius is like a decimal, like a weird decimal, something you can't work with, then I would expect you to multiply it all the way out. But I'll probably with those have in the direction saying something like round to the nearest 10, okay, instead of leaving in terms of pi. All right, so for just the area one, before I do the second. Go through those. Both of these problems, right, 3/8 and 4.5 are manageable fractions, okay, or manageable decimals. So I would say leave these in terms of pi. All right. The reason I say that is if you've got the radius given to you and it's a fraction, guys, when you actually go through and you do your pi r squared part, and you actually plug in the 3/8, don't make it a decimal. Because it's already in fraction form. When you square a fraction, remember all you're doing is you're squaring the top number, you're squaring the bottom number. So when I do 3/8 squared, it'll become 9/64. And then I would say definitely leave this in terms of pi. That would be a problem I would. The pi just goes with the numerator.
Only with the numerator?
Yeah, because it's pi over 1. So when you multiply the fraction, it goes to the top. Okay. Okay. 4.5, guys, a 0.5 is a half, right? So that's basically 4.5. So I would expect you guys, even for this one, leave it in terms of pi. But before you do that, I would probably suggest you make that a fraction. Right? 4.5 is 9/2, correct? That would be 4.5, right? Would it be? Okay. So, same thing here. It's a manageable fraction. I would say leave this in terms of pi. If it was like 4.78, something like that, then I would probably on that problem say round it out to the nearest tenth or nearest hundredth or whatever. But anything that's already in fraction form or anything that's a decimal that you can convert quickly to a fraction, those are the ones I'm going to say leave in terms of pi. All right, so what's 9/2 squared, like as a fraction? 81/4, right? The square top and bottom, and then the pi just goes on the end. Okay? So I wanted to do is mostly just to remind you of what happens when you square fractions. And just to point out, if you see ones like that, guys, don't convert them to decimals. Okay, I want those in terms of pi. All right. Now, where this gets applied into the newer stuff today. Okay, the sector. Like I said, guys, the sector is essentially just a portion of it says a portion of the entire area of a circle, but the sector, when they reference that in the book, it's connected to the center of the circle. So you're typically only looking at slices. Okay, like I said, when you do this, when they first present this back whenever, elementary school, middle school, whatever it is, it's probably brought up as like a slice of a pizza or pie or that kind of thing. Okay, and it's because when they reference a sector, like I said, it has to be connected to the center. All right, which means that you're going to be doing central angle stuff again, which leads you to arc measure, like we talked about yesterday. Okay, so formula-wise, it's the exact same proportion with the circumference changing to area. But it's still the sector over, like if I change this instead of like the A and the M measure of AB, this is like the sector over pi r squared. So it's the portion of the area you're looking at over the entire area equals the measure of the arc over 360, which is still, the measure of the arc is the portion of the circle over 360, which is the entire thing. And just like yesterday, guys, right, there's 3 places I can plug in a number. The 360 is the only thing that stays constant. So that means, just like stuff yesterday, there would be technically 3 types of problems I could give you. Okay, I could ask you to find the sector, the measure of the arc, or the radius. Right? But in general, the problems are going to be similar to yesterday. Right? Have the radius given to you, give an angle measure, and they'll just say find the area of the sector. Okay, now, what you need to be getting in the habit of doing, just to make it easier on yourself and using smaller numbers, is start looking for angle measures that will quickly reduce the fraction. The first problem I do won't be that way, okay? But there's a couple afterwards, because I'm going to go through a few of these. That there are going to be certain degree measures, guys, that you should automatically convert to a small fraction. Like 60 degrees. If I give you 60 degrees, it's 1/6. So instead of over here doing 60 over 360, you just do 1/6. All right? If I give you 45 degrees, it's 1/8. Right? 120 degrees would be 1/3. These are just things that you need to get in the habit of looking for. Okay? All right, so first problem I'll do is this one. All right? Just like yesterday, guys, these should be pretty easy. The questions might be worded this way. Probably on the test I'll word them the exact same way also. I won't say find the area of a sector. I'll say find the area of the shaded region. Because it's kind of leading you into what we'll do tomorrow. But for this one, you'd have to look at it and go, oh, the shaded region is basically a slice of the entire circle, so it's a sector. So I use the formula that was just up there. All right, so this would go x over 16 pi, correct? Right, that is pi r squared, right? I threw that up there. No, you're good. All right, equals 80 over 360. All right, and 80 might not be a common one that I would say you have to like know a quick conversion to. But just like yesterday, I said if you got a 0 on the end of it, remember you can just kind of cross it off because you're dividing it by 10. Like they both top and bottom divide by 10. If you want to further reduce it, that's fine. Again, right? It would be like 2 over 9. All right, so now, just cross multiply, right? And like I said yesterday, if the variable's on top, I don't care about multiplying the 36 over, that's not what I need to do. Okay, all I gotta do is take that denominator, multiply it up there, and get it by itself. So what's 8 times 16?
Okay, times 16.
Yeah.
128.
What?
128.
28. So this is 128 pi over 36 square feet. And it'd be good if you reduce it, but if you don't, I'm probably not going to take off. Okay? All right, now, what I was saying about the quicker things, and ones that aren't necessarily of this, and can I go past this guy? Yeah, all right. Like if I do the one down here, if I saw the problem that I have that's number 3, wherever the heck I got it from. If I saw that one, and I was doing it, I highly doubt I would actually go through setting up an entire proportion for it. Because the way I would look at it is I go, 60 degrees. I know 60 degrees is 1/6 of the entire circle. So all I have to do to actually get an answer on ones like this, if you start realizing things like 60 degrees is 1/6, you just do pi r squared, which in this case, pi r squared would be 64 pi, right? Correct? I would just do 64 pi over 6, so that's 1/6 of it, and it could be done. All right, yeah, I know it reduces, and it would be nice if you reduced it, but if you didn't, I wouldn't take off. Okay? So ones like where you can recognize that, and like I said, guys, 60 degrees, basically 1/6 of the circle. 45 degrees, 1/8. 120 degrees, 1/3, right? 90 degrees, 1/4. Those are kind of the major ones that you'll look for there. Okay? Anything other than that, I would probably say you're going to go about setting up a proportion. Just like I would have done the last one, and just like if I did this one here, the one up here, it would be as x over pi 8.5 squared, right, equals 200 over 360. Okay? All right, so just kind of keep that in mind. Look for these angles. Okay, because if you have them, it'll make life a whole lot easier. Also, I'm not going to work that whole thing like that, but can I go past this? All right. Also, if you've got problems like these two, I'll go through both of these, or at least set up. Like the one, if I gave you one like number 5, even with that one there, the number 5 one, I really wouldn't even expect you to do anything with the proportion. Because they're giving you these little marks right there all around the circle. What do those little marks mean again? Congruent, right? So it's broken up into congruent parts. If I said, what's the area of that shaded region there, how many are shaded? Now, how many are shaded out of all the slices? 3. How many total slices are there? 8. So it's 3 out of 8 times whatever the heck the area is. Right? So I'm just doing that. I don't need to know what the actual degree measure is. It'd be 45. I just don't need to know that. Okay, in order to do the problem. I just need to know if you've got things like that and all the regions are exactly the same and they give you a couple shaded in, seriously, just break it up into 3 shaded regions out of 8. And then just multiply it by the pi r squared part, which in this case is 25 pi. And just remember when you're multiplying it, right, that's 25 pi over 1, right? So when you actually multiply them together, you just multiply it by the top. So this one here would be 75 pi over 8. Okay? Now, this one over here, though, since these aren't all 4 of the exact same regions, I couldn't do it that way. I would actually need some degree measures here. All right, so I would, like if I was doing the one over here, I would actually set the proportion up as x over 11 squared pi equals, I need the angle over 360. So in this case, I would need the actual angle length. Which, what do you think I'm going to put up there for an angle length?
210.
210, why? Why? Why?
Because 75 and the side, an angle C, those would be congruent. And we subtract that from 360.
Yeah, so these are both 75. Put those together, that's 150. Take that away from 360, that's what's left. Okay? So this would be like x over 121 pi, 21 over 36, correct? Okay, so we go down to 7 over 12 now. Okay? So what is, what's 121 times 21? 121 times 21. Wait, 2,000 what?
No, 2541.
Oh, 2,000. 2541. Pi over 36. And that is squared. Okay. Look,